Hello. In this broadcast, we will try to explain how to improve MySQL database performance using some performance tuning tips. Okay, let's see them in detail. With growing data volumes and changing workloads, database performance tuning and MySQL query optimization are now necessary to maximize resource utilization and system performance. SQL tuning requires extensive technical expertise to write and understand different execution plans. That's why writing clean SQL statements is only possible after accumulating knowledge and experience with dry fields. Tuning is very time consuming because when you have a large number of SQLs, it brings a bit of uncertainty to find out which statements must you tune up and which one should you leave. Since every statement is different, their tuning approach also varies. That's why preventive best practices must be applied during the development. Identifying the performance killer factor helps you to avoid over-provisioning and reducing the costs. It also gives you a correct metrics to decide whether moving data storage or adding server capacity will bring improvement or not. Once tuned properly, the database gives high performance results by eliminating unnecessary task load, but also optimizes the MySQL database for faster data retrieval. Indexing of all the predicates. All predicates in where, join, order by, and group by clauses should be indexed. Improper indexing of SQL queries can cause table scans, which eventually lead locking problems and other issues. That's why keep indexing scope with only used predicate columns in your SQL queries. Avoid using functions in predicates. Database doesn't use an index on column if column is used as a parameter of predefined function. That's why avoid functions in predicates. Predicate like followed by wildcard causes a full table scan. In most cases, this wildcard usage brings major performance limitations. That's why try to avoid using wildcard at the beginning of like predicate. Avoid unnecessary columns in select clause. Instead of using select star, always specify columns in the select clause to improve MySQL performance, because unnecessary columns cause additional load on the database and degrades performance. Use outer join only when it is necessary. Using it unnecessarily not only limits database performance, but also limits MySQL query optimization options, resulting in slower execution of SQL statements. That's why use inner join if possible. Using union and distinct operators without any major purpose causes unwanted sorting and slowing down of SQL execution. Instead of union, using union all brings more efficiency in the process and improves MySQL performance more precisely. The order by keyword sorts the result set in predefined statement columns. Although the statement brings advantage of getting the sorted data, it also causes performance impact in the SQL execution, because the query first needs to sort the data for producing the final result set, causing a bit complex operation in the SQL execution. Prefer using programming language features. Don't use MySQL as a queue. Queues cause problems for two major reasons. They serialize your workload, preventing completion of tasks in parallel. This type of table contains work in process jobs and historical data from already completed jobs. It not only adds latency to the application, but also adds hindrance to MySQL performance tuning. That's why do not periodically check and update table using multiple threads. You can prefer Redis as persistent queue instead. Choose the right hardware specs. You need 4 fundamental resources to make database functions: CPU, disk, memory, and network. If any of these doesn't function properly, it ultimately affects the database server and results in poor performance. Make sure that there should be a right balance between them. Selecting servers with fast CPUs and large disks, but having less memory, which eventually kills the performance. In some scenarios, adding memory can highly improve performance when it comes to the magnitude. In most cases, the overutilization of disks affects directly to database performance as well. Pagination. Applications that paginate to data tables typically group and sort in a way that they can't use indexes. They mostly employ limit and offset function. That causes the server to do a lot of work generating then discarding rows. You can find optimizations within the user interface itself. Instead of showing the exact number of pages in the results and links to the individual page, you can just show a link to the next page. On the query side, instead of using limit with offset, you can select one more row than you need, and when the user clicks the next page link, you can designate the final row as the starting point for the next set of results. Subqueries. Prefer a join where possible instead of subqueries as your data grows. Subqueries are the subject of intense work by the optimizer as the data size grows. The more data tables have, the subqueries are slower. The less data tables have, subqueries have equivalent speed as joins. The subqueries are simpler, easier to understand, and easier to read. But most of the time, you have performance issues due to growing size of data. Use MySQL Query Cache. MySQL provides database query caching, which caches the select statement text and the retrieved result. Whenever you make a duplicate query, MySQL can bring the result from the cache without parsing and executing the query. It will reduce the processing load in database against subsequent repetitive queries. Use Memcached for MySQL caching. Memcached is a distributed memory caching system. It speeds up applications having large dynamic databases by storing query results in a memory to reduce the pressure on a server. Whenever read request arrives, a caching layer provides results from the memory and reduces the number of calls to database. For example, Java Spring Boot caching provides a framework with eviction policies using external caching solutions such as Memcached or Redis. Memcached implements a multi-threaded architecture by utilizing multiple cores. Therefore, for storing larger datasets, Memcached can perform better than Redis. I hope that the best practices I gathered may help you to get more performance from your data layer and database. Thank you for listening.